It says the recording will start soon. Now.
Welcome. My name is Anjali Temple, and I am a math instructional coach at Bailey's Elementary School. I will be presenting to you today along with my colleague, Helen.
Hi, my name is Helen Rose, and I'm a preschool special education teacher at Bailey's Elementary.
All right, so today we'll dig into the foundational concepts of early numeracy. We hope that you'll leave with understanding around the importance of mathematics for even our youngest learners. Take a moment to think about your experiences with mathematics. How might you describe your experiences as a young student learning mathematics? What successes and challenges are you currently experiencing with teaching mathematics? What might be some hopes you have for today's session that is focused on early numeracy, learning, and teaching? Consider jotting down your ideas on a piece of scrap paper. We'll resume this presentation in a few minutes. All right. Often literacy is the focus of preschool programs, and mathematics is a bit sidelined. One study calculated that at preschools where kids spend 6 hours a day, math gets an average of only 58 seconds per day, not even a full minute. Vanderbilt University education professor Dale Ferran reports in her recent study of preschool classrooms that math was intentionally taught by teachers only 2.5% of the day. This is quite saddening because mathematics content can be a vehicle for supporting IEP goals and language learning goals. Students who are learning English might find mathematics content more accessible, and educators should capitalize on this possible strength. Also, early mathematics skills have the greatest predictive power, followed by reading and then attention skills, reports a psychology squad led by Greg J. Duncan in School Readiness and Later Achievement, which was published in Developmental Psychology in 2007. Math skills at school entry predicted math skills and even reading skills in 3rd and 2nd grade, respectively, better than reading skills at school entry. Parents know about the importance of reading to their children, but often they are not clued in about the importance of integrating counting and other mathematics skills into daily routines. Parents and educators need to know that the more math-oriented activities kids do before kindergarten, the better they'll understand math in school. Additionally, early math skills foretell higher aptitude in high school math and higher rates of college enrollment. And a 2014 Vanderbilt study determined that for both males and females, mathematical porosity early in life predicts later creative contributions and leadership in critical occupational roles. Preschool programs, as well as parents, must not only acknowledge the importance of mathematics for young learners, but provide learning experiences that prioritize both numeracy and literacy. We hope that this presentation unpacks the skills and understandings associated with counting and provides practical ideas for preschool programs and parents who want to be focused on mathematics in addition to literacy. Here are specific learning intentions for today's session. First, we'll build groundwork in the foundational concepts of number and counting. Then we'll examine models for the conceptual developmental of children's counting. And finally, we'll think through the implementation of activities that promote numeracy. We'd like you to engage in a counting activity before we unpack the skills and understandings associated with counting. So find a collection of objects in your space. Maybe you have a collection of paper clips or a collection of toy cars, or maybe there's a bowl full of fruit nearby. Whatever collection you find, figure out how many items are in that collection. I'll pause for a moment so you can accomplish this task. All right, hopefully you had a chance to count a small collection. Counting can appear to be quite simple when accomplished easily, as you just did. However, unpacking the details of what children do as they count reveals their understanding of a complex, interconnected process, a process that is anything but simple. All right, now we're going to view a short video clip of a child, Muhammad, counting some blue teddy bears. This video is featured in Carpenter and Frankie's book, Young Children's Mathematics. And I actually have a copy here. It's called Young Children's Mathematics, Cognitively Guided Instruction in Early Childhood Education. As you're watching, think about the skills and understanding that this child demonstrates. I need to figure out how to play the video because it doesn't. Hold on. Helen, if you could just let me know if the video is playing.
Okay.
Hear that? So in here, I have some bears.
Yay, blueberries.
Yeah. Can you count those for me?
1, 2, 3, 4, 5, 6, 7, 8.
How many bears do you have?
8.
All right. So as you were watching, what are you noticing about this child's mathematical skills and understandings? So think about that for a moment. You might have noticed that Muhammad was able to correctly count the collection of blue bears. He pointed to each bear as he counted, demonstrating one-to-one correspondence. He was also able to say that there were 8 bears in the collection, which demonstrates cardinality. The importance of learning to count cannot be overstated. Counting is the foundation upon which number concepts and skills are built. The ability to count accurately, flexibly, and with understanding supports children's future success in mathematics. While children's ability to count accurately is often still emerging, the details of their actions demonstrate an intuitive sense of the intricacies of counting. Even when their thinking may seem wrong or incomplete, there is often an underlying understanding of core mathematical ideas of counting that can be productively built upon. right, so here are the fundamental counting principles from Carpenter and Frankie's book that I just showed you, Young Children's Mathematics, Cognitively Guided Instruction in Early Childhood Education. In the video we just viewed, Mohammed not only demonstrated counting skills, but he also showed that he understands these fundamental counting principles. So one counting principle has to do with the understanding that there is an ordered sequence of counting numbers. That is, numbers are always assigned to items in a collection in the same order, starting with 1. Then there's the one-to-one principle, and it's about understanding that exactly one number from the counting sequence is assigned to each item in the collection. This understanding is often referred to as one-to-one correspondence. And then last, the cardinal principle is understanding that the last number in the counting sequence assigned to the collection represents the number, or like the total amount of objects in the collection. So these are very important counting principles, and that's our foundation that we need to build with our youngest learners. All right, here is a more detailed list of the knowledge, understanding, and skills associated with the ordered sequence of counting numbers. So children must learn that the number names, they have to also come to understand that the counting numbers appear in a fixed sequence. Children also must recognize that numbers are not repeated in the counting sequence. As children deepen their knowledge of the counting numbers, they build understanding around the base 10 number system and can apply a few rules to generate the names for larger numbers or larger numerals. Also, children eventually connect spoken numbers to the written numerals. All right, so now we're going to watch 2 additional videos. Again, these videos are featured in Carpenter and Frankie's book, Young Children's Mathematics. As you watch each video, make note of the knowledge, understanding, and skills that Miley demonstrates around the counting principles that has to do with the ordered sequence of counting numbers. All right, so I'm going to play these videos. Helen, again, if you could just give me a thumbs up to make sure it's working, and I'll mute my mic so we don't get feedback.
I would love to hear you count. Can you count for me? Count as high as you can count.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
Nice. Do you know what comes next? Can you go any higher?
1, 2, 3, 4, 5, 6, 7, 8, 9.
Awesome. All right. All right, check out my collection of pennies. Could you help me count them? Here, I'll point them out. How many pennies are there?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 30, 40, 50, 70, 80, 90, 70, 80, 20, 40, 50, 60.
Awesome. Thank you, Miley.
All right. So what are you noticing about Miley? Take a moment to think. In the first video, you might have noticed that Miley was able to say the counting numbers from 1 to 11. She was prompted to go beyond 11, but she was not able to. I think she only went up to about 9 the second time. In the second video, Miley counts a collection of pennies, and she's able to say the counting numbers from 1 to 20 accurately. You might have noticed that Miley was able to count further in the sequence when she was counting the collection of pennies. This is important. This is an important noticing because researchers have determined that many young children can count further in the sequence when they are counting a collection of items than when they are asked to count only out loud as far as they can. So consider providing young children with many, many opportunities to count collections, since counting with objects supports children in learning the counting sequence. I do recognize that Miley, when she was counting the pennies, after about 20, she wasn't able to say the counting sequence correctly after that, but she was still also showing understanding that there's some patterns and that you need to keep going in the counting sequence because there was more items left to count. So even though she was doing some inaccurate stuff, we're also noticing that she has some understanding, some initial understandings that her teachers and parents can build upon. All right. We're now going to move to the one-to-one principle. So here is a more detailed list of knowledge, understanding, and skills associated with the one-to-one principle. Children must come to understand that the numbers in the counting sequence are assigned to each object in the collection until all the objects in the collection have been assigned a number. Also, children must understand that no two objects can be assigned the same number and that the assignment with numbers start with 1. Over time, children develop strategies for keeping track of which objects have to be counted. For example, some children arrange items in a straight line as they're counted, while others might touch and move the items as they're counted. Consider counting together with young children and emphasizing matching the action of pointing and touching or moving each object with the saying of a single number word. You might also pose the question, how will you keep track of which ones you've counted and which ones you haven't counted? Some children might benefit from putting objects into a container as they count, such as during cleanup, as it slows down their count and focuses them on one object at a time. Keep in mind that it takes time and a range of experiences for children to develop understanding of the ability to use the one-to-one principle. All right, so now we're going to dive into the Cardinal Principle. Here's a description of the Cardinal Principle. After many experiences with counting, children come to understand that the last number recited in the counting of a collection of objects represents the number of objects counted. To support the development of the Cardinal Principle, consider waiting for the child to complete their count of a collection of objects and then follow up by asking, so how many are there? If children are able to explicitly state how many, then you'll know they have some understanding of the Cardinal Principle. If they don't have full understanding of the Cardinal Principle, often children will just recount when you ask them that follow-up question. You might also consider gesturing over the entire collection while restating the final number. It might look and sound something like this. Like you might just use your hand and say, like, all together, there are 6 toy cars, or whatever the object is. Other ways to get at the cardinal principle include saying to the child, here are some blocks. How many are there? Or do you have enough to give me 4? Asking children to make sets of objects of a given size rather than counting a collection also can focus them on the cardinal principle. So again, just asking them to give you a specified amount helps. It's a slightly different than asking them to count a collection, and it helps really focus on that cardinal principle. Okay, we're going to watch another video. This video is a video of Fiona counting a collection of rocks. And again, it is featured in our book here by Carpenter and Frankie. As you watch the video, make note of the knowledge, understandings, and skills that Fiona demonstrates, especially around the cardinal principle. All right, I'm gonna give me a thumbs up, Helen, make sure it's playing, and then I'm gonna mute so we don't get feedback.
Okay, Fiona, how many rocks are there?
1, put one right here. 2, put 2 right here. 3, 4, 5, 6, 7, 8.
How many are there?
There are a lot.
Could you give me 5 rocks?
There's 5. Here's 5.
Did you give me 5?
Mhm.
Can you double check that you gave me 5?
5 and 5 is 5.
All right. Thank you.
All right, so what skills and understanding does Fiona demonstrate? Take a moment to think about that. You might have noticed that Fiona produced an accurate counting sequence and demonstrated one-to-one correspondence as she counted the collection of rocks. However, Fiona did not show understanding of the cardinal principle because she was not able to explicitly state the total amount of rocks. She was also not able to give 5 rocks to the teacher, which provides additional evidence that her understanding of the cardinal principle is still developing. All right, we're going to watch one more video that shows Leonardo counting bears. This video is featured in Carpenter and Frankie's book, Young Children's Mathematics, Cognitively Guided Instruction in Early Childhood Education. Again, as you watch the video, make note of the knowledge, understandings, and skills that Leonardo demonstrates, especially again around the cardinal principle. There we go.
All right. What do you notice about these bears?
Red.
Yeah, that one's red, huh?
That might be yellow. Green. Blue. Yellow. Red.
Can you count the bears for us?
1, 2, 3, 4, 5, 6, 7.
How many bears?
7.
Can you count one more time so I can hear you nice and
1,
clear?
2, 3, 4, 5.
How many bears?
5.
Can you put 3 bears into my hand?
1, 2, 3. Right, and put down.
All right, so what skills and understanding does Leonardo demonstrate? Take a moment to think. You might have noticed that Leonardo took time to line up the bears. When he counted the bears, he was able to produce the counting sequence to 7, but he did not count with one-to-one correspondence. When asked how many bears there were, he did demonstrate the Cardinal Principle because he was able to explicitly state the total number of bears. He said, there's 7. Of course, this total amount was incorrect because he was not counting with one-to-one correspondence, but he was showing understanding of the Cardinal Principle. When asked to give 3 bears to the teacher, he completed this task correctly, providing additional evidence to support that Leonardo has understanding of the Cardinal Principle. So as I hope you notice with these different videos that kids, as they're learning to count, the path they take will vary. Some kids are going to develop one-to-one correspondence before the Cardinal Principle or vice versa, and all of that is normal. It's not a straight path for students and children as they work on learning these three key components of counting. Bob Wright is a researcher and an expert in the field of early number instruction. He has identified some pre-number topics that include sorting, matching, classifying, and putting items in one-to-one correspondence. Those might be topics that if you are a preschool teacher or even if you're a parent looking at books that are out there, a lot of those topics are some traditional approaches to teaching mathematics for very early students. And earlier approaches to number instruction prioritize these number topics before instruction around numbers because it was believed that these pre-number topics provide the basis for learning about numbers. However, Wright's research, which is a little bit more recent, suggests that pre-number topics can enhance the development of logical and number knowledge, but these topics are not necessarily a prerequisite for early number knowledge. So what that means is we should not hesitate or delay teaching our youngest children about numbers and counting. And as we had discussed in the beginning of this presentation, mathematics is so vital for young learners that we should not delay or avoid providing them with experiences and activities that are focused on counting a number. We are doing them a disservice if we avoid counting a number activities or if we focus on only literacy. So numeracy is just as important as literacy, and we must take on the responsibility of providing rigor in early mathematics instructional programs. So this means early mathematical instructional programs should prioritize skills around counting and number knowledge. So it's really, really important that we don't delay that, even though maybe our experiences as kids or maybe curriculums don't always have those topics highlighted, but our newest, most recent research is really telling us that counting a number is really, really important, even for our youngest students. All right.
Now we're going to explore some activities to build early math skills in young children. Many of these activities are inspired by the book Developing Math Concepts in Pre-Kindergarten by Kathy Richardson. As you learn about these math activities described in the next few slides, consider these questions as you think about implementing the activities with children. What mathematical ideas are being explored in this activity? What mathematical knowledge might children need in order to engage in this activity? How might you scaffold the activity so all children can have access? What language supports might you provide for children? What questions might you ask while children engage in this activity? One activity to work on subitizing at home or in the classroom is to take turns rolling a die with your child. Have your child count how many dots they see. Can your child count without touching the dots? At first, your child may need to touch each dot to count how many dots. In the classroom, this is a good transition activity. It can be paired with movements. For instance, have the children take turns rolling the die and counting the number of dots. Children can move, jump, dance, hop, turn, stretch, stomp the corresponding number of dots on the die. Playing dominoes is another way to practice subitizing. An extension activity is to have your child create a set of objects to match the dots on the dominoes or the dots on the die. For example, your child rolls a 3 on the die or draws a domino with 3 dots, and your child creates a set of 3 pom-poms or 3 toy cars. One activity to support the development of one-to-one correspondence involves your child listening to and counting a sound that they hear. Hit a xylophone or another musical instrument, or simply clap your hands 4 times. Can your child count how many sounds they hear? Can your child make a set of counters with the same amount? A good option for tying early literacy skills and number sequencing is using children's literature, poems, finger plays, and songs. There are a large variety of books, finger plays, counting songs, and poems that will build early math and literacy skills. These activities build children's early computational skills. Children are asked to add 1 more or subtract 1 less. To support children's understanding of finger patterns, you can use your fingers to support what is happening in the text. For instance, in the text 5 Little Monkeys, you can show your child 5 fingers and take 1 finger away as the monkeys fall off the bed. You can ask your child, how many monkeys are on the floor? How many monkeys are on the bed? You can model the math language 5 minus 1 equals 4. In the classroom, these are great activities to do on a flannel board. A list of suggested titles is included in the resources at the end of this presentation. Now for cardinality. An activity to practice cardinality is to put small objects such as Unifix cubes, counting tiles, or Legos in a paper bag. Count the objects as you put them in the bag. Ask your child how many objects are in the bag. Shake the bag. Ask the child how many objects are in the bag now. This activity provides children with many opportunities for practicing cardinality, for counting, and supports their development of conservation, the idea that the number of items in the bag does not change. Now we're going to look at using the environment to support learning. Here are some photographs of ways to develop math skills by using the environment. What mathematical ideas are being explored in this activity? And the next slide, creating sets outside with acorns. Here's a photograph of children working to bring back acorns in dump trucks to match the card they were given. What scaffolds or supports do you notice? How could you extend this activity? And on the next slide, here are some photographs of children creating sets of cotton balls, which we are pretending is snow, and sorting bears by colors. Take a moment to consider the questions listed on the slide. Now we're going to move on to counting collections. Counting collections is a perfect way to practice early math skills at home and in the classroom. Place a variety of objects to count, each in a separate Ziploc bag. This activity can also be used to develop vocabulary such as descriptive words, soft, hard, the names of colors, size concepts, and to build sorting skills. You may ask, how many red pom-poms do you have? How many yellow pom-poms do you have? Do you have more red or yellow? How do you know that? Remember to ask how many do you have after the child counts to see if they have cardinality. And the next slide, why counting collections? Why is counting collections a useful activity? It targets many areas of development: language, fine motor skills, and social emotional skills. Children have the opportunity to observe from their peers. It's fun and motivating. Students can pick the bag of items based on their interest. Students can count higher when provided with a collection of items. When students are given a larger number of objects, a teacher or caregiver may tap into a student's knowledge not observed with smaller sets. Students may understand the base 10 of our number system, but not have the correct sequence for team numbers yet. Caregivers can use collections of items readily available at home, such as Q-tips, spoons, straws. And the next slide, counting collections. Now, you may wonder how to get started with counting collections. Start in a way that makes sense to you. Observe the process of your child's counting. What does your child know? What do they need to know? How can you support their learning? Follow your child's lead. Ask them open-ended questions. Tell me, what are you doing? How do you know that? How will you keep track of the items you counted? Ask your child questions that target math concepts. Can you count the items? How many do you have? Additional ideas for math questions are included at the end of this presentation under resources. Opportunities to count collections can be incorporated throughout the day. It can be done during one-on-one time, small group, and circle time. Counting collections allows for differentiation and individualization of instruction. You are able to meet your child where they are and extend their learning. You can allow your child to take initiative and organize the items in a way that makes sense to them. They may sort them by color, line them up, or stack them. Counting collection targets many of the math principles highlighted in this presentation. Which mathematical principles do you notice? And then the next slide. Counting collection provides an opportunity to count a variety of objects: pom-poms, small toys, cars, buttons, acorns, rocks, spoons, crayons, pennies. Different objects will allow different counting strategies. For instance, it may be easier to stand bears up for counting, slide coins to count, and place crayons in a bag to count. You can provide your child with different tools to support their counting, such as cups, bowls, felt squares, number tracks, empty ice cube trays, or empty egg cartons. An extension activity is to have your children represent their collections on paper or invite your child to count with a collection with a peer partner. And the next slide. Extend your child's thinking by having them count larger collections of objects and count different kinds of objects. Different types of objects will take up different amounts of space. 15 pennies will look different than 15 toy cars. Place objects in a jar and have your child practice estimating how many are in the jar. Write a numeral on a paper or a whiteboard. Do not state the written numeral. Have your child create a set with that many items. This activity incorporates numeral identification. Ask mathematical problems such as, what if we take 2 away or give you 4 more? What are some ways you can use counting collections in your daily routine with children? And on to resources. Here are some links to resources with suggested questions to ask and ways to find math at home and in the classroom. And the next slide, here's a link to some suggested titles of counting poems, songs, finger plays, and books. And the next slide with the quote. In conclusion, we want to be realistic in our expectations for young children and mindful of not pushing them too far, while also doing away with artificial limits. It is our hope that counting collections and other early math learning activities can provide one of many spaces where children's ideas matter, their varied strengths are valued, and students and teachers and caregivers alike feel successful. And that's a quote by Nick Johnson and Natalie Gaxiola from their Counting Collections article. And the next slide. What ideas do you want to hold on to as you build early math skills with your child? What are some possible takeaways as you plan activities to support your child's early math learning? On this slide, you'll see our emails. Please feel free to reach out to us with any questions. Thank you for joining us today.
Yes, thank you all.
Thank you.